Hello, so last year I made a video about this Mi Air Pump 1S device, made a teardown of it. This year I have the Mi Air Pump 2, so this is the 1S and that's the 2, and we're going to be having a look at it. I'm going to do a teardown first, and then we're going to do some testing and see how they're different and how they behave. So it comes in a box. I don't have the box for this one anymore. These are the accessories that this one came with. It also came with a carrying pouch. So let's get it opened up. Both of these are from AliExpress. They cost pretty much the same, about 47 Canadian dollars after discounts. So it's for reference. Comes in a box. That's the unit itself. Instruction manual. In Chinese. Is it? Set that aside. Also in the box, we get another carrying pouch. This one's almost exactly the same as the one from last year. And of course, we have some accessories, which is new. It's plastic. This is plastic. Looks like it's plastic inside. Does the old one fit in? Okay, so I've missed that. We have in the box a pressed valve adapter and a air needle, just like last year. Pretty much exactly the same, except the pressed valve adapter is slightly longer now. Opening this up, we can see the actual device itself. It is about the same size. It's slightly wider than last year. I don't know if you can see that. It is slightly wider unit. Thickness-wise, it is slightly thicker, but overall, about the same size and weight, I would say. They both have these, the metal rubber hose ends. I think the hose on the 2 is slightly longer than the 1S. Just by a little. So on the 2, everything's just slightly larger. On the screen, we have some notable differences. We've got a battery indicator, which is missing on the 1S. I would buy this one over this. I think it's worth it. There's actually no way to tell if the battery... Actually, I guess this one on the 1S, it has a indicator that goes from, I think, orange to white, I believe, but this is kind of nice having that. I think the user interface is about the same. You can adjust the pressure from the home screen like that, and both of them have flashlights. Yep, for sure. So we have a much brighter flashlight this year, which is excellent. Be useful at night if you're out in the dark somewhere. And I think there's a little flashing mode as well. So there's an extra mode on this one. I think there's an extra scooter mode on this one. But, so at this point we can see inside both of them. There's slightly different construction. Both have a PCB on top here with the charging port on it. But in this case we can see a cooling fan right under there. On this one the cooling fan is a blower. I'm not sure if you can see that. There's a blower in there that operates, the motor is oriented this way. But on this one the motor is oriented this way. And if I can find the picture I'll show you. This one has a slightly different internal architecture. The motor is oriented this way, and the piston's horizontal on this one. But on this one, the motor's horizontal, and the piston's actually up here, vertically pushing towards this outlet hose. Now we can see the insides. You can see there's quite a lot of internal layout changes between the two models. If we come here and look around, on the back we can't really see anything yet. There's, this is an oil-free sort of pump, little rubber seal. So I would assume that if this got too warm, this would start wearing out, or the lubrication would fail, and this could presumably melt, because it's made out of plastic. So it's probably important to keep this thing relatively cool while using it. This, I think, there's a video somewhere of someone replacing this piston. I don't know where to get it, but they were able to find one, and they replaced this when theirs wore out. And otherwise, the cylinder head, this little valve, I assume. It's got a little spring on it, and it, I think, seats into the top of the, I think it seats right into the top of the piston. Got a little sealing ring around here. It seems like this, seems like these channels are quite thin. The way this is made actually is, behind these screws, there's a there's an O-ring seal, and actually what they do is, I think they drill a hole down here. This is all one piece, and they drill a hole into here. They drill a hole here, and that way they have access to the inside, so you can see the hole they've drilled down there. And I believe they just cap the holes off with these screws with O-rings underneath them. It's kind of a clever way to manufacture this without having to cast all these little cavities into here. There's a fan here that blows air up across this and out of the side, sort of. The ducting situation is sort of ambiguous. So this is the casing of the 1S. That's for the battery. Got these rubber grommets that mount the motor assembly to this, which probably helps with noise a little bit. This is quite a noisy unit, though. Overall, this is a pretty complicated design. It's kind of difficult to assemble and disassemble. After taking that one off, we can see the internals of the two. So, looks like there's a lot of cooling improvements in two. There's fins over small on both the cylinder head and the cylinder block. Got one less gear. This is still plastic. It's got a much larger bearing. Got a counterweight here. And of course you have this fan here, and we have a much more defined ducting system now. The edges of this fan are very close to the edges of the body, so this fan is going to be pushing air in. It seems like this one is a bit difficult to take off compared to the last one. The battery cables have to be unsoldered to take this one off first and lift this up and access the bottom one. Having a look at the pump from version 2, we can see that this time the cylinder head, the block, is basically cast out of the same bracket as the rest of it. For the main gear, we've got like a nice big ball bearing as the holding that in place, and we got this. We got a slightly beefier cylinder rod, connecting rod now. As for the valve, it's pretty much the same thing. Got this valve seat. This time it just goes on top of here. Comparing the two main boards, we've got an extra button on the 2S, no, the 2, sorry, versus the 1S. Same, I think the general idea of the display is the same. It's got this cover over all these individual LEDs, but as you can see here on the newer one, we have the battery icons. Pretty much the same button layout. There's an extra button here for some reason. That's probably a microcontroller, and this time I think it's they've done away with that LED driver chip. Of course, on the back, this is the 2. I think we have the same battery charge chip. It looks like most of the electronics are fairly similar. Some changes, but nothing too major. I think the biggest one is the addition of the battery indicator. That's a nice touch that this one is missing. Looking closer at the batteries from both of them, this one's from the 2 and this one's from the 1S, and you can see that there's been a number of improvements. First of all, this laptop style blade connector is much better at making reliable connection while taking it apart than this one. This one does some funny stuff if you take the board off while it's still powered. It'll switch the motor on and off randomly, which is quite dangerous actually, because there's no pull down on the gate of that transistor or something. Any stray, contact or contact bouncer or whatnot can trigger that. This one doesn't seem to have that problem, although I'd still be careful when taking it apart. So this time the BMS FETs are now surface mounted onto the board, different package. You've got your sensing resistor, 2 milliohms this time. On here we've got a little battery management chip here. One of the nice things about the new battery management system is it's got conformal coating on it. So if this ever gets wet, there's a much better chance of this continuing to protect the battery, as opposed to something like this where it would likely just drain it completely or damage it somehow. And you can see it says Lith Plus P20. There's 2 cells. Same on this one. They both have 2 cells. There's a bit more insulation on this one. This one's made by Li Shen. And 7.4 volts, 2 amp hours, 14.8 watt hours. This one's actually made by Hoto, which is another brand of Xiaomi's, I believe. Hoto also makes an air compressor. I think I recognize some of these components from it. Here, this time it's 14.4 watt hours, very slightly smaller, 7.2 volts. It's a fairly similar battery pack, all things considered, size-wise, but I think this one's got a few upgrades to it. Looking at these 2 motors, we can see that they're both marked similarly, actually. Having seen both taken apart now, I think the biggest differences between them are, number one, the cooling. I think the cooling on this one's going to be better because there's a different kind of fan. It's going to be more airflow and more cooling, more thermal mass on the heat generating components in this one. It's also simplified and there's less mechanical stuff. Of course, you've also got the same displacement, but you've got a better, 25% more airflow on this one, supposedly. And the battery packs are slightly nicer on the new ones. Overall, from a repairability perspective, I think they're both fairly difficult to take apart and work on. I'm not sure if that's really a problem, because I don't know where you would get these replacement parts. I know people are asking about that on the last video, but I'm not really sure where you would buy any of this. I know you can get the motors, but I don't expect the motors to be a point of failure. Everything in here seems fairly reliable. Overall, I like the design of the 2 a little bit better than the 1. There's a lot of small refinements, but overall it's a much bigger change than 1 to 1S. And if I was buying one right now, since they're the same price, definitely get the 2. Oh, and the battery indicator, I think that's really important. That's a really nice thing that they added in version 2. Here I've set up a simple experiment to test some parameters of these two pumps. They're going to be bringing this 235/45/R18 tire up from 0 to 34 psi, and while they're working, I'm going to be measuring the time, the temperature, the pressure, the current, and the voltage across the motor. The current is being measured by a shunt resistor, a 1 milliohm shunt resistor in series with the motor. The oscilloscope is measuring both the voltage across the motor and the current. And unfortunately, there's a lot of noise, and I wasn't able to get that figured out in time for this experiment. So I'm just going to be reading the average current from the waveform off the oscilloscope. This isn't a super scientific test, but hopefully we'll get some useful information. The temperature on the 1S is being measured at the side of the cylinder, and the temperature on the 2 is being measured at the end of the cylinder head. This was because of limitations in what parts were easy to probe from outside of the case, since I didn't want to take the case off and affect the temperature measurements. So we'll see what the results are like in a moment. Here I have all of the data from the test. I've tabulated it in Excel, not in a particularly clean or organized fashion, but you're welcome to take this data and do your own analysis. I might post the results of this in the description if I can find a way to do that, so that you can do your own analysis on it. Let's just move on to the conclusions. So starting from pressure and flow, here we can see that indeed the 2 does reach the target pressure of 34 psi quite a lot faster than the 1S, which is about what we expect because Xiaomi says there's about a 25% time difference between the two. Both of them are fairly linear in shape. The pump doesn't appear to be slowing down with pressure increases or with decreases in the battery voltage as the battery drains, which is great to see because it means they're using high quality batteries and the pump is staying strong throughout. I haven't really run this test with higher pressures since it would take a lot longer, and I don't really have anything that's designed to hold pressures up to the 150 psi that this pump claims to be able to run at, but if people are very interested in it, maybe I can find a way to test that. I've also taken that same data and done a quick calculation just to find out the airflow. For the 1S, we're looking at about 0.3 CFM, and the 2 around 0.41. The way I did those calculations is essentially I estimated the volume of the tire. I haven't included the foam or the specific geometry of the rim or anything. I just made some quick estimations based on numbers from online. This is what I basically got. Convert that to cubic feet of air pumped at the target pressure and divide that by the time, and it turns out that we get about a 25% less amount of time to get to 34 psi on the 2 compared to the 1. And you can see that here, it's actually about a 29% decrease in time required to get the tire from 0 to 34 psi. In that sense, the 2 is definitely quite a bit faster. And also interestingly, the 2 uses about 20% less energy from the battery to get there. It's using about 5.53 watt hours compared to 7.18. And the main benefit of this is that since the battery on both is 14.4 watt hours, if you're using the 2, you're actually able to fill this tire up about 2.7 times, where on the 1, you would only be able to do it twice. And I did notice the 1 was kind of sounding like it was slowing down halfway through. So I'm not sure if the battery will be fully dischargeable, but definitely the 2 is more energy efficient. And since they both charge at about 10 watts, 9 to 10 watts is what I saw, in order to get, let's say, 1 fill of energy or 5.53 watt hours, it'll take roughly around just a bit more than half an hour. So with the 2, you can do a full fill up on just about half an hour of charging. So if, for example, so this is actually one of the main disadvantages of the battery powered pumps, where if, for example, you want to use this in an emergency and it's leaking and you need to fill it up every half an hour, if you got one of the plug-in ones, you'd be able to use it as often as you wanted. With the battery powered ones, you kind of have to wait. So it's good to know that with this one, you have like 2.5 sort of fill-ups in the battery, and of course you can always just keep it charging, and as long as you can make it 30 minutes between charges, it should work continuously for your purposes. Next, let's look at the power consumption on these two lines. The colors aren't ideal, but it seems like the power consumption on the one is much more constant than on the two. This is a good sign, I suppose, because seeing this being, from a physics point of view, it should, with higher back pressure, you should be seeing a higher load on the motor. But of course, here you don't really see it, because it seems like on the one, there's a lot of power being lost just in friction and in how long it's running for, and on the two, it's running for a shorter amount of time, which probably explains the efficiency difference. And it seems like a lot of, you see this trend with increasing pressure and power, which is reasonable. Now, both of these pumps are running at a fairly low power. They're about 35 watts-ish. And that was much lower than I expected, because a lot of the plug-in pumps that you'd see advertise something like 70 watts or so. This is reasonable because the batteries in this pump are fairly small, and so is the motor. So you're looking at about 35 watts. It's fairly reasonable. Now, moving on to temperature, if we add temperature to that graph, we can see that despite having much better cooling, the two kind of overlaps with the one quite a lot here. I think this is possibly explained by the difference in temperature measurement location, since the two is being measured on the cylinder head, which probably gets a bit warmer than the cylinder body, especially because on the two, the cylinder body is actually connected with the motor and the gearbox, it's one piece. So that's why you see the faster cooling from when it stops running to when it cools down to 50°, compared to here with the 1S, which takes a bit longer to do that. Most of the cooling seems to be happening down to about 60°. So this is about the time from here to here that you'd have to wait. Looking at the rate of change here, this is about the time you'd have to wait before using it again, if you want to keep the temperature reasonable and let it cool down for a while. This is fairly reasonable. I like how the two cools down faster, but keep in mind that this test was done, outdoor temperature was 12°C or so, so if you want 25°C or so, probably add 10°C to all of these measurements here. It seems like the temperature control on both of them is fairly reasonable still, but the two definitely has a little bit of an advantage here. That's about it for all of the data analysis I did on this test. If there's anything else you want to know, feel free to ask in the comments or use the data and do your own analysis. In any case, hopefully you found something in this video to be interesting or helpful. If you have any questions, feel free to ask them in the comments and I'll see if I can address them. And in any case, thanks for watching and have a nice day.